Talk by Roald Hoffmann is co-sponsored by the Department of Chemistry, and we're grateful to Gary Molander, the chair of chemistry, for his help. Also to Peter Struck, who's here representing the Benjamin Franklin Scholars program, which he directs, and we're also co-sponsored today by them. Many of the students here are Franklin Scholars. This lecture continues our series on color with an exploration of the history of indigo blue. I'll take the occasion to alert you to our next event. It was up on the screen a minute ago. Our next event in this series on November 12th, a presentation by Farrah Griffin on new shades of blue, black women singers in the 70s. That'll be here in Rainey again on November 12th. By the way, note that the event originally scheduled for November 5th, our Humanities at Large event on alternative textual and interpretive traditions of reading the Bible, has been moved to next fall, rescheduled a year later owing to unexpected knee surgery. It's not that funny. He hurt his knee. That's Peter Stallybrass, our good friend. Anyway, we are going to do that event. It'll be great, but it's going to be a year late. Events in the Color series, those of you who've been coming to this really great series so far, are generally introduced by this year's topic director, Chi-Ming Yang. But today we asked our colleague in the philosophy department, Michael Weisberg, to do the honors. Professor Weisberg works on the history of scientific models, especially on models in the computationally complex sciences, including chemistry. He's one of, I think, very few humanities faculty who are on the affiliated faculties in the Institute for Research in Cognitive Science here and the Center for Cognitive Neuroscience. His book, Simulation and Similarity, Using Models to Understand the World, came out from Oxford University Press last year, and the year before that, he edited a volume, also from Oxford, on the work of Roald Hoffmann. So he's our resident Hoffmann expert, and Michael will introduce our guest.
Good afternoon to all of you. It's my honor, a great personal pleasure to introduce to you our speaker, who is also, as Jim alluded to, a friend and mentor. Roald Hoffmann is the Frank H.T. Rhodes Professor of Humane Letters Emeritus at Cornell University, and he really is a model of everything that the Penn Humanities Forum promotes. His work has always been concerned with understanding the natural and human worlds, drawing on the resources of chemistry, physics, computer science, poetry, and philosophy to accomplish this understanding. His intellectual journey began in a quiet attic in Poland, where he learned to read while hiding from the Germans. He continued his schooling and then university education in New York City and made his way to Harvard University, where he studied physical chemistry, focusing on the development and application of quantum mechanical methods to the study of organic molecules and their reactions. He continued this work through a junior fellowship at the Society of Fellows, where in collaboration with R.B. Woodward, he began to study concerted reactions. The chemistry students among us here will no doubt be familiar with the Woodward-Hoffmann rules. This was one of the most important outgrowths of this collaboration. Roald's accolades run in a list way too long to enumerate in a short amount of time, but they include the Cope Award, the Pauling Award, the National Medal of Science, and the 1981 Nobel Prize in Chemistry shared with Kenichi Fukui. He's also a highly accomplished science educator, poet, playwright. His monthly columns in American Scientist, his PBS series, The World of Chemistry, his books, Chemistry Imagined, The Same and Not the Same, and Old Wine and New Flasks have showed millions of people around the world the beauty and inner logic of chemistry. And most recently, his new play, We Have Something That Belongs to You, has been workshopped in a collection of his philosophical essays, as Jim alluded to, has been published by Oxford University Press, right on the table over there if you'd like to look at it. There's so much more I could tell you about this remarkable chemist, humanist, and scholar, artist, but like you, I very much look forward to hearing about the color blue. So please join me in welcoming Roald Hoffmann, who will share with us this evening the alluring story of the color indigo.
Yes, let's see, I think I'm on. I think we have the seats pretty full. I'm very happy to be in a Pan-Humanities Forum because just of what was said, that the world of the arts and the humanities is, to me, intertwined with that of science. And that is the story that I will tell you through the story of Indigo. So let's begin with this. So here are a few women happy about what they have done. And what they have done is to dye some fabric with indigo. And in that, they have participated in a process that goes back over millennia of people using this pigment, working with it to achieve, to satisfy in part our desire for this particular color. The story, of course, of pigments in general, which is being explored in your series, is an important and old one. Here are, and it is a story that's tied up with chemistry, because there was chemistry before there were chemists. Nobody waited for creatures called chemists in order to do transformations of matter, and that is what chemistry is. The art, craft, and business originally, before it ever was a science, of substances and their transformations, of things and things changing. And here are three masterpieces of art, an Egyptian wall painting from Luxor, Thebes, the Gate of Ishtar, originally in Babylon in the center, then through a feat of imperialism for a change not American, finding its way to Berlin, and then at right, an Hellenistic wall painting, actually I think from Egypt, but a period of realistic representation that preceded the Renaissance in Italy by a mere 1,500 years. The green or the blue in these is not the lapis lazuli ultramarine, which was available to artists if they had good enough patrons. It was available to Giotto then to paint the Scrovegni Chapel in the Italian Renaissance. The blue in all of these was an object of human manufacture, a pigment Egyptian blue, a byproduct of Egyptian mastery of enamel and of glass making, essentially a glass frit with a copper pigment to give it the color. The point here is that there is blue, there's a desire for blue. Turns out that this particular blue, Egyptian blue or ultramarine, could not be used to dye fabrics. So textiles have a different requirement for being able to be colored than do inorganic surfaces, as you see over here. Now we have, the problem with textiles, though, is that they being organic in nature, whether they are proteins, as they are in the case of wool or camelid fibers, or if they are cellulosic materials, as they are in the case of linen or cotton, they in general don't survive very well. Here is the oldest, one of the oldest textiles perhaps that we have from the European Asian part of the world, and that is a carpet from southern Siberia, remarkably finely woven from about the 3rd or 4th century BC. In our hemisphere, things are much better in terms of survival. And this has to do with the climatic conditions in South America. And the particular survivals we have, I hate the word pre-Columbian because of the colonialist implication in it, from these cultures that preceded even the culture that we know best in the Andean region. The Inca had a rather short run of 100 years before the Spanish did them in. These are the cultures preceding them, Nazca or Moche, Wari. And these a remarkable sophistication in both the dyeing of the fabrics, the colors that were attained, but also, as you can see, the design. These are abstract, they're representational. I'll show you a couple more. The techniques like tie-dyeing in the one at right also are also pretty sophisticated in these. The blue or the green in these is the dye that we want to talk about ultimately. And it comes from a certain source, which I'll tell you in just a moment, which is a source which is not from a plant, but from a snail. And that the plant pigment was used subsequently, or all the time along, also in other parts of the world. Here you see at left some of the beautiful West African adira, the indigo dyed fabrics, and over at right, a manufacturer in Yemen of fabrics dyed in indigo. The pigment that was used in those South American textiles had a source, and those date incidentally from roughly maybe 200 BC till the arrival of, but those particular cultures predate the Incas, so they ended around 1200 or 1300 of our era. The dye that I want to talk to you about is called Tyrian purple in one of its incarnations, and I don't have a fabric. I couldn't find what I thought was an authentic fabric to show you, though I wouldn't be surprised if it's not somewhere outside in one of the exhibit cases. It's just I haven't found it. But you see here a toga, not only worn by fraternities, but predating them, as you see in the statue. But what I have to show you at left, of course, is not a fabric, but it's a mosaic. But it actually captures the color pretty well. And this is a mosaic from Ravenna, and it captures that toga aspect. So the Romans, this dye, I'm giving it away, was precious. You'll see in a while when I give you some statistics on its manufacture. It was tightly controlled by the Romans, the Tyrian or royal purple. And so there were regulations on when consuls or praetors could wear it, but a full toga dyed in the Tyrian purple could only be worn by the generals in triumph, which had a very specific designation at that time. And so, or by the emperor, or by others on certain occasions. So there were tight regulations on the wearing of the purple, a preciousness that in turn reflected the expense of the pigment as it was produced. Meanwhile, while the Romans were regulating the manufacture of the snail indigo, which came to them from Phoenician sources along the coast of what is now Lebanon and Israel largely, while they were regulating this under the pain of death, another culture was writing that a very similar pigment, I think actually an identical mixture, into their own religious beliefs. And this is a passage from one of the more interesting parts of Numbers. You see here, the Lord said to Moses at bottom left, "Speak to the Israelite people and instruct them to make for themselves fringes on the corners of their garments throughout the ages. Let them attach a cord of blue to the fringe at each corner." The word for blue here is the Hebrew word techelet, which is just off the slide at the top, but it doesn't matter. It's a different word than the modern word kachol, or other words used for blue in the Bible. This follows then just before a crucial rebellion against the authority of Moses, the rebellion of Korach, which is interpreted in various other Jewish texts as being around the use of the color blue. I will not have time to tell you about that. Now that blue is in a fringe that you see, and that fringe, tzitzit, is tied to the corners. You see it in a prayer shawl today, a talit, but it is also there at the edges of the ritual undergarment that's worn by Orthodox Jews. So in particular, since you cannot avoid running into some Hasidim here or there, if you watch their kids, you will see that these fringes are hanging out of the corners of their garment, of the undergarment. It's a poncho-like light undergarment that they wear, and here this rabbi in Israel is wearing that, and he's wearing a cord of blue. The blue is tied into a fringe, and since this is a Jewish matter, there are 8 different ways of tying it, and they all fighting with each other. And you can win a merit badge in tying these as a Boy Scout in Israel. It's actually quite amazing. So there's a whole thing around this. But if you've noticed the little Hasidic kids, by and large, the fringes are all white. And there is not a blue fringe in them, even though it's mandated in numbers. And the reason is that the religious source of that ritual blue, one of the numbered commandments the religious Jew should follow, the mitzvot, that already was lost by the time of the redaction of the Talmud around 600 AD. So it was lost, and I'll come back to that loss eventually. Now, the blue was very important. I don't know if you've seen a page of the Talmud, but it was initially oral law, then written down, and eventually, of course, printed. And this is the way it is printed today, or that's been printed since the invention of printing. There is an inner part, with some of it bold-face, called the Mishnah. There is another part that's running the central text, that's running through this. This is this brief summary of the laws, and this is the main text. Then there's a commentary by Rashi, by his grandsons. There are citations on the side. You can see that the people who studied this for 1,500 years would have no trouble with the law, and I mean American law. That is, this is a structure of citations and of references which is elaborated tremendously. Now, here is the actual text in the middle. What they are doing, this is the first book of the Talmud. So what is the Talmud? The Talmud is about 50 or so, in the old days I could say encyclopedia-sized set of books, but that's lost, okay, or on the way. So it's about 50 volumes, and the Bible, despite evangelical claims, is not enough to run your life. So in order to run your life, you need a discussion of the things, and that is what the Talmud, the rabbis in the period of the writing of the Talmud did in these 50 volumes. So sure enough, there is a volume on divorce, or maybe it's 2 volumes. So all these things are like, but this is the first volume, and this is on blessings. So these are about regulations, about when to say the blessings that a religious Jew should say. And a particular discussion is from what time in mind they recite the prayer, the creed, essentially in the morning. You're supposed to say it in the morning. So how do you know it's morning? It's a little problem in Alaska in a certain time. But how do you know it's morning? So the rabbis discuss it. One says is when you can distinguish between a wolf and a dog. And someone says, no, it's between an ass and a wild ass. Typical Talmud stuff here going on. But the eventual resolution is at the top. And you can say, you can decide when it's time to say the prayer, when you can distinguish the blue in your fringe from the white. So it's a simple color test about that we do not see colors at night. That is the eventual decision. But you can judge from this the importance of the thing. We have not had until recent times something reasonably qualifying as a ritual Jewish textile from the biblical period. One was found in a burned fabric at Masada and has been analyzed, and it is this blue from snail origin. The range of colors that one obtains is partially represented by this range. The intensity of the color is a product of the dyer's art. So you've seen, so it can go to a navy blue dark, but it can go toward the sky blue, but then it has this reddish tinge. And we know now something about what gives the reddish extreme, the violet extreme, and the blue extreme in this pigment. And we know that it's the same mixture of pigments that is there in the Tyrian purple and in a ritual blue, which aside from those fringes is also prescribed in a high priest's robes in another part of Numbers. The sources of this are 3 snails living in the Mediterranean, 2 murex species. The names of the species have been revised in recent times, and hematoma here. These snails have a gland. Here the gland has been stained in order for it to be visible. Otherwise, it would look the same color, the same sort of flesh-colored beige that you would see it normally. That gland, the pedigial gland, is accessible only if the snail is killed, though there have been various claims of being able to milk the snails for the pigment. But usually the snails had to be killed, the shell broken, the snail extract, and this gland about 1 centimeter long, 1 millimeter wide, extracted. And as you cut out this gland, and you say put it on a piece of cloth or on your hand, before your eyes, it turns in some seconds from this beige color through a pus yellow green to a blue, which stains your hands pretty well. Pretty much, I would make it analogous to black walnuts if you've handled them. And so it stains your hands, but it washes out in about 2 days. So you keep on washing, you get rid of it. But the point here also is if you do this to a fabric, it'll also wash out. And nothing has changed about whether you can sell a fabric. If something washes out in 2 or 3 washings, it's not going to sell. So so one has to do something else, and they did it in ancient times. I'll tell you what it is in just a while, to make a fast dye from that fabric. These snails are quite remarkable. These snails they're carnivores. They eat other snails. Here was the way that Pliny described of fishing for these snails, which to this day works. You put a chunk of meat into a basket, you lower it, and the snails go for the meat. So that's what you see over here. They will attack other snails if no other snails are around. They're cannibalistic. They are a veritable chemical factory. When a snail is attacked, the snail retreats and closes the operculum, the closing. What these snails, Murex trunculus, for instance, does is they have a little proboscis, and in a gland they secrete essentially a reasonably concentrated solution of sulfuric acid. They proceed to dab it on their proboscis, and they touch it to the outer carbonate shell of the other snail. They bore a hole through the shell using the acid to dissolve the carbonate. Once they penetrate to the flesh, from another gland they inject a neurotoxin into the other snail, which causes the other snail to relax and open up, and then they eat it. It's this is, how do I know this? I'm not a biologist, but I have a friend, a landsman in Israel, Ehud Spanier, who's a professor of biology at University of Haifa, and he has told me this story. So these snails are quite remarkable, and but it is this particular gland that is the source of the pigment. Now, this was the source of a major industry of the purple for the Romans, but also for, in the Jewish ritual use, which was the material was made by the Phoenicians as well. It took place along that shore that I mentioned, but also here are some other places. And I and my wife were, for instance, in a rather different place, the island of Djerba of Tunisia, where we stood in a shell dump of these snails. So this is the other part of the story. About 10,000 of these snails had to perish to produce enough dye to dye a Roman toga. So that is a very, I'll show you later a picture of one of the manufacturers, but the result is snail dumps, though there is some feeling, shell dumps, there is some feeling that they were also eaten. So the dumps may be also from the result of leaving food sources. There have been, in the middle slide over here, you see some remnants of the purple remaining in a jar. And if you want to know more about this, there's a wonderful book by Dominique Cardon on natural dyes and their sources, where much of the story is told. Anyway, what you can see is this is widespread around the Mediterranean. One way to judge the importance of this is to look at this object, which is much magnified. This is a coin of the city of Tyre, or Tyre, in Tzir in Lebanon now, and it pictures on the coin at the bottom the foundation myth. So this city made its living from the manufacture of the snail indigo. What you see there is the foundation myth. The foundation myth is that Hercules' dog was wandering along the beach and bit on a snail, and its snout was colored purple. And that is how the purple was discovered. That's not a bad sculpture. That sculpture is just 2 millimeters high of that snail. But the point here is what you put on your coins, and it gives you an idea of the economic value of this pigment. Not only in the Mediterranean, but also in the Sea of Japan, in the Indonesian region, and especially around the northern coast of South America, there are other species of snails which produce that purple, that same purple. And here, I cannot forego showing you some of these incredible textiles from the Wari, Moche, and Nazca cultures. Incredible degree of sophistication in the handling of textiles. These are dyed with the snail indigo. A mixture perhaps different, but fundamentally the same. Meanwhile, and all along, preceding the use of the snail, and during it and post-dating it, there was a plant source. And the region that's marked in a darker blue here, in this blue here, a tropical region as you see, but extending to the southern part of the United States, is the region where the indigo plant was grown. Family Indigofera, related to the pea family. Here is a field of indigo in California. this plant from a long time immemorial, was used to obtain a source of the blue. But the blue that was obtained from this, and I'll tell you some of the ways in which it was done, the blue that was obtained was on the blue side and not on the red side. So it turns out the blue and the red are related pigments. I'll show you what they are in a while. And the snails produce those two pigments depending on a species in varying amounts and depending on a gender and the season. And just for fun, they change gender every few months. So that this is a complicated story biologically for various reasons. But here is the indigo plant. Here is from another cultural source. This is Diderot and d'Alembert's Encyclopédie. So this is we're now in mid-18th century, and they are illustrating the industry of the plant indigo. These are indigo vying vats that they're illustrating. The price difference between the snail indigo and the plant source indigo, even though the snails could supply the redder part of the scale, but dyers wouldn't mix some other red. There's another story of the red colors, but we're going to remain with the blue. To get that purple effect, the price difference has been estimated to be the order of 100,000. People will forge for a price difference of 1.5. People have made forgeries of orange juice. You may remember stories about that. I mean, there can't be very much money in forging orange juice, but there is, depending on the quantity. But so from biblical times and to the Romans too, people tried to substitute the plant indigo for the snail indigo. And the Talmud has a long discussion of how to tell the plant indigo from the snail indigo. It is essentially simple analytical chemistry, and they conclude at the end that they cannot tell the difference. And good reason, because it's the same molecule. But what they say is they then classify the sin of substituting the plant indigo for the more precious and ritually required snail indigo in the class of sins which will be punished not in this earth but in the afterlife. A much more serious category includes relatively few sins in it. Rather interesting. Here is a dye vat from West Africa that you see here. Here you see, of course, another area where the indigo is valued, which I haven't shown you before, and that is in Japan. I will say something more. Japan is about this in just a while. Japan is about the only place in the world, roughly, where there is a viable commercial industry of plant indigo dyed fabrics. The rest has been, unfortunately, run out by chemistry, of which I'll tell you soon, but not quite yet, because there is also this light blue area over here, which, as you see, extends all the way to the lower parts of Scandinavia and the British Isles. And this is the place where another plant producing the indigo could be grown in much more temperate climates. And this is woad in English, weid in German, pastel in French. And this woad Let's see if I have a quotation. Yes, here's a quotation from Caesar. All Britons, it sounds better in Latin than in English, but you can read it. And you thought that being blue had something to do with aristocracy. This is where blue blood comes from. The English used the woad to dye themselves. Houses in Thüringen in Germany were painted on the outside with Weid, with that blue from this particular plant. Okay, now, if you are wondering what the heck two different families of plants, quite different parts of the plant kingdom, are doing, producing the same pigment as 5 different species of snails around the world. If you ask that question, if you think about that question, you are on the way to being a scientist. So I will not hide the answer from you. The precursor, or at least a partial answer, the precursor to the indigo molecule, which I'll eventually show you a tiny bit of chemistry, is half of that molecule. And that half, it comes from a biosynthetic route to making one of the essential amino acids. And that biosynthetic route and the precursor of indigo is there in every organism from E. coli on. And I could make this blue from you. Except you don't make too much of the precursor, not enough to be a good source. So now the question still remains, why do some organisms, like these snails, in that particular gland, why do they overexpress, overproduce this particular molecule? This is the kind of question which my late colleague Tom Eisner asked all the time and explored. You can be sure that it's not for our use as a pigment, okay? It's there because it's of some other use to that particular organism. And that remains to be discovered. It's the same question as, do you think that the mint plant that makes catnip is doing it for your use to attract your cat? It's doing it for some other reason. And these kind of questions are very interesting. But underneath this is a shared biochemistry. Okay, eventually, cultural evolution catches up with biological evolution. And this happens in 19th century. Its beginnings are in Germany with the first synthesis of a pigment that was commercially attractive, desired, and valuable, mauve, by Perkin, a student of a great German chemist working in England. Much as Haydn worked in England, so did August Wilhelm von Hoffmann 200 years later. And the Germans proceed to run off with the synthetic dye industry. Great German chemical firms are founded. What you see here are some of the samples from one of the great science museums. This is the Deutsches Museum in Munich. You see here samples of the first aniline dyes, the first synthetic dyes, a great commercial success. And indigo is not quite an aniline dye, but it's in there. And it's interesting here at left is a facsimile of a letter from a great chemist, Adolf von Baeyer, to Heinrich Caro, the head of one of these companies, Badische Anilin- und Soda-Fabrik, BASF, exists still to this day, the only remnant of what were 3 great German chemical companies. And Bayer is writing to Caro that he has determined the structure of indigo. And there he draws the chemical formula in a letter. And within about 7 years, BASF puts on the market synthetic indigo, about 1890 or so. This is interesting culturally too. These are some of the labels, as you see, of the indigo, of the synthetic indigo that BASF is selling. Now notice the exotic nature of the labels. So what is going on here? It's the same thing as when the European rediscovery of porcelain took place, a reproduction of Chinese porcelain, a very well-dated piece of industrial research involving an alchemist from 1700, first decade of the 18th century, 1700 to 1710. The first pieces of porcelain made by the Meissen manufacturer, of course, have Chinese and Japanese patterns on them. And the reason that the plastic covering of your tables looks like wood is the same story in some way. So you want to sell this, you want it to be as exotic as the original natural product was. So that is part of what is going on. Pot is also trying to sell it to there are a number of very interesting stories on dyes. There is another story which I don't have time to tell you, but within 2 years of the first sale of the aniline dyes in Germany, they are found in remote villages in Persia, being used to dye Persian carpets. Technology spreads very, very quickly. And there's a story of one of those dyes ruining the black in those carpets. Finally, a molecule. This is dibromo indigo. The bromine is you can see where the bromine is. If you take the two bromines and you replace them by hydrogen, you have indigo. The indigo is the blue range of the scale, available from snails and from plants. The reddish end of the scale is the dibromo indigo. Nothing natural is pure. The purest things of this world are in the laboratory. The aroma of a good Cabernet Sauvignon has 900 molecules in it, at least. And maybe not all of them are necessary, but nature, for good reasons, the processes of evolution are inherently divergent, so they create multitudes instead of creating pure substances. But so when I say those are the two main components of the dye, some mixture of them. Now the bromine compound is only in the snails because there is much more bromine, not too much, but much more bromine in salt water, in ocean water, Mediterranean seawater, than there is in fresh water. So the bromine product characterizes this as a marine natural product, and the other one comes from other sources. So here's the molecule. There are a number of interesting features. I'm interested in this molecule for reasons that have to do with my research now. And so along comes cultural evolution, chemistry. The Germans are making indigo. In the Chemical Heritage Foundation down the road from here, there is a box of there's a wooden box, and inside is a canister of BASF indigo. It was retrieved from a German submarine sunk in First World War. The Germans were trying to continue in a period before 1917 against British attacks on the seas with still neutral America and in a trade. And the indigo was so precious, still, even though synthetic, that they could use the submarines to try to deliver the indigo. These are all stories of the complex interrelation of economic science and culture. Along come, what is this? This is probably an oil refinery. It's not a chemical plant, but it stands good enough. It stands for for what chemistry can do, and eventually indigo could be manufactured in large enough quantities to do what? Well, this. Now, I take it right off because you shouldn't do that. You shouldn't do that. But let me try to say in words what I want to say. So the first thing is that, well, what I'm saying is if our kinds of views were around, then the fashionable young man of Renaissance Italy would be dressed as you saw. But there's another story. 2 billion pairs of jeans are made each year, mostly in China. Each pair of jeans requires to dye that is indigo that dyes it. It's immediately washed out for fashion reasons, in some cases. But it takes 1 to 3 grams of indigo, about the equivalent of dyeing that emperor's toga, to dye that pair of jeans. Someone has estimated that if you had to use plant indigo to produce the same number of jeans that are being produced today, you would need to plant every arable inch of the Earth's surface by indigo plants 10 feet high and over on top of each other. So I want everyone here who is wearing jeans to be grateful for chemistry. That's the cultural evolution part of this. It's made this particular great contribution of America to world culture possible. Okay, now here's again these blues. I don't have time to tell you another part of the story, which has to do with the Maya blue, a beautiful blue that is in Maya art, here in 2 examples. Actually, that is indigo finding its way stabilized. Indigo is not sufficiently stable to be used in paintings, though it was used in Japanese prints for a period of about 100 years. But it is not used very much on inorganic surfaces, but here it survived in Maya art because it was combined with a clay, and the clay protected. The indigo went into little interstices in the clay and was stabilized by that. This is a beautiful detective story only of the last 30, 40 years or so, where we know something about it. Now, if you want to know more about chemistry, you have here in-house at this wonderful museum the world's expert on the chemistry of the blue dye. And this is Patrick McGovern, who is illustrated here, dealing with another aspect. He calls himself, he is a biomolecular archaeologist. I wish I had that title. Here he has done a lot since he explored the story of the blue around 20 years ago or more. He has done much more in recent times on the history of the production of intoxicating beverages. And he's obviously involved in some research here. But this is something about that molecule. Here is that half of the molecule, and eventually it's coming to the molecule. Okay, so now we come to the story of what everyone who trying to dye the textile with the indigo is facing, and that is true of both the plant material and of the snail material. That is, if you dye those, if you use those, apply them directly to the fabric, they do make the fabric blue. And if you repeat it a few times, it becomes a dark blue, but it washes out. So now we're dealing with the chemistry of dye stuffs, an interesting story, but basically what's happening, or not, if I can reduce it, oversimplify it, the indigo molecule is not absorbed well by the molecules that form the textile, which in biblical times were wool and linen. Cotton was just coming online, so to speak, in that time. Wool and both of them are very different molecules. Wool is a protein, linen is a cellulose fiber. They don't absorb the blue too well. So there has to be a chemical process done. And how this was done in the old days is described here in a papyrus that's called the Stockholm Papyrus because that's where it is, not because that's where it comes from. But it says, put about a talent, that's a measure of woad in a tube, which stands, they use woad in this translation, but they mean actually the plant indigo, which stands in the sun and contains not less than 15 metrites, that's something, other measure. Then pour urine in until the liquid rises over the woad and let it be warmed by the sun. But on the following day, get the woad ready in a way so that you can tread around it in the sun until it becomes well moistened. One must do this for 3 days. Some of the prescriptions say that the urine should come from men who have drunk strong drink. That makes the best. Urine is a chemical. It contains the molecule urea and other molecules. And the urine solutions are acidic initially, but they become basic. I'm using some chemical terms, which I tried to avoid. And what happens is that the molecule of indigo, which is over here, under the action of an alkali, a base, and that is what the fermenting urine is. Incidentally, if you go to Pompeii, and if you go outside the dyer shops, you'll see big vats that look like this. Those are to collect the chemicals for the next day's work. Or if you go to Fez in Morocco, you will see still some things of this. 2 hydrogens have to be added over here to produce another form. And that form, or this one, in this form, which is colorless, you lose the color, blue. In that form, it is absorbed, it's mainly through this kind of ionic bonding here, better into the fabric of the dye. It forms chemical bonds to the protein or the cellulose. So you've done away with the color blue. But now, if you take it back out, there is a reversal of that process. I'm desperately trying to avoid the words reduction and oxidation. There is a reversal of that process, and the oxidation is carried out by the oxygen of the air. That's why it was called oxidation. And the blue returns. Now here I'm going to show you this process a little bit. Here is an archaeological site, an ancient dye works in what is now called Tel Dor. It's where the Carmel Mountains turn into the sea, a little south of Haifa. And there is a Phoenician dye site. And I did some research for a book that we did about issues of science and Jewish religious tradition. I'm here, I have captured one of the snails. We couldn't use it to make the dye because the snails are protected in Israel. But we wrote a book. Some of my books are there, and I'm very happy to sell some of the books to you. They cost about the price. It's much harder to make a living as a writer than it is as a chemist, I assure you. And so that That's if you have children who want to become chemists. Please, let them. We wrote a book, Shira Leibowitz and I, and in the process of that we had to do some research, and here are Shira and I. Let me tell a little story about this. We're holding 2 of the 3 species of snails that you saw me illustrate before. So when you write a book, you need on the back cover, you need a photograph of the authors, preferably smiling, okay? So, but this was a collaboration. And it's very hard in a collaboration to get a single picture in which both partners in the collaboration are smiling. So here we had one. Now, Shira, as you can see, is observant, orthodox, and in fact, she would not go in the water with us, but I went swimming with her sons and husband, and but we're smiling. So I love the picture, and I said, let's use this for the book. And Shira said, I have to talk to my rabbi. Okay, now so I thought that it was my nipples that were the problem. Yeah. But no, it was the bare legs. So we cut off the picture here, and then it's in a book. Okay. The research was very hard for this, as you saw before. We actually went on with 3 young men who've started a business since. The business is called Ptil Techelet, the thread of Techelet. And we are standing in a Phoenician dye pit with shells around us in the walls of this pit. And we are recreating the process of dyeing some wool with the blue. And we are using snails, but we're not using the protected Israeli snails, but we're using the same species from the most polluted part of the port of Marseille, which are imported at great cost into Israel. And from these we're allowed to make, they're starting a business where they are making this material. And please don't worry, the yellow color is not because of the chemical that was mentioned aforementioned. It is just that these are actually cut out snails. We cut out by hand a good number of the glands from the snails, and the stuff that goes, it smells awful. The sun is shining, these things are rotting. We're cutting out organic material, and that's what gives it the color. Now, these young men, we're going to recreate this, I'll show this to you, but I want to tell you a little bit about the problem these young men have. We have, not we, but the scientific experiments now fairly clearly show that the biblical Techelet, is a mixture of the indigo and dibromo indigo. I think it's pretty much identical to the Tyrian purple. But it is not a pure substance. It is a mixture, and it always was a mixture of the two. And the craftsman could make it into most any color. So now the ability to make this was lost by the Israelites because maybe even the Romans had something to do with it by trying to restrict the Tyrian purple trade so that the Phoenicians would not make it for the Jews. But it was lost by the Israelites by AD 600. So this is a commentary on Numbers, and it says, and now we have only white, for the Techelet has been hidden. Moreover, and the Romans lost the art of making the Tyrian purple, despite good descriptions by Aristotle and Animalia and by Pliny. they lost the art with the fall of Constantinople and their control of this region. Purple was rediscovered in the 19th century by a French zoologist who is cruising in the Mediterranean, and one of his Maltese fishermen picks up a snail and draws across his white t-shirt a Maltese cross, and it turns blue. And the biologist goes on to investigate that. That's the rediscovery. But it was lost, but it's not that it was just lost, it was the loss was converted into an allegory. The allegory is that this is what the Jewish people have lost, and it was tied in the Kabbalah to the Messiah not yet coming. The Messiah not yet coming, that when he comes, the blue will return. So now you see the problem these young men have. They are, with scientific reasons, they are all observant people. In fact, one was an accountant, one a lawyer, one something else. They're all graduates of Yeshiva University, and they told me, I wish we had paid some attention to our chemistry course when we took it at Yeshiva. But they didn't. But now later in life, they got together to found a business to remake the biblical blue. There is another story about another such business in 19th century Poland, which I could tell you. But these young men, their trouble, so there is no central religious in Judaism. There are a lot of leaders of local group, essentially gurus, equivalent Hasidic masters, the head of one community or another one. What they have to do is they have to go around rabbi to rabbi and convince that rabbi so that he can tell his followers that this is the biblical blue and that they should buy from these guys some of these fringes which are colored blue, and then they would be reconstituting a mitzvah, a good deed that they should do as a religious Jew, one of the lost good deeds. And they have trouble. They're doing this, they're slowly making, but I would say look at the Hasidic kids around and see how many of them have a blue fringe. And you'll see that there are very, very few in there. Here is actually, I come to the end of the story, and now there is another thing. Here I am in a moment standing. You can see we're using a beaker, but we did the old method. And we dipped into this yellow mass here, yellow solution, with the snail glands, with the indigo in there. We are using a modern reducing agent. We changed the indigo from blue to colorless. It looks yellow, but it's actually colorless. And then we dipped in the fabric, and I'm drawing out the fabric. I'm drawing out, not the fabric, I'm drawing out the wool out of the solution. And in the time it takes me, a few seconds to draw it up there, you can see it turning blue. Okay, now what I want to tell you is that this is a spiritual moment. And this comes from an atheist that I'm telling you about this. That is the act of repeating a process, and that is why those women were smiling in that second slide too. The act of repeating a process of dyeing a fabric with a source which was used 2,500 years ago to dye that fabric. Knowing so much more about it, but there is still, think about this. Think also about the alchemist dissolving gold in aqua regia, precious gold, it vanishing. What faith you must have that it'll reappear. A faith based on craftsmanship and the history of doing this before. So equal here, imagine those craftsmen and Phoenicians who are taking this blue, which from 1,000 snails or 10,000, precious blue, and then throwing it into urine and cooking it up, what faith they must have in order to think that it would reappear. And in modern times, by my doing that with these young people, in some sense, I have shared through a very material process a spiritual act of faith, and I can feel it as well as they can. Thank you. Good. You got jeans on. I forgot this is Japanese. So let me say, while we're waiting for the questions, I have a Japanese tie from that manufacturer on. So what is remarkable about Japan, and I just was listening in a book to Henry Kissinger say the same thing in different words in his recent book about world order. What's remarkable about Japan is not that they can make cars and CD players better than we can. What is remarkable is that they can do so while retaining a respect for their traditions. You can see this if you go to Japan, if you walk into that archetypical product of Japanese culture, a Japanese department store. Has 8 floors, there are little girls in front in sing-song voice greeting you as you go in. You go up there and every floor is full of the latest. It's not quite the supermarket of electronics that you imagine, but it's full of the latest products. And then there's one floor where they sell ties like this and ceramics and bamboo objects. And that's where art galleries are in Japan. They are in department stores on that floor. And that's telling you something about the country and the culture.
Thank you. It was a struggle to hear from the very, very back. And so I'm afraid I missed some fundamentals. I wondered how long blue was lost, did you say?
Yes.
Was it most of recorded history then? It was gone?
The blue from plant sources was available all along. Some of you may have seen that workmen's clothing in both, I think, France and in Japan is often blue. And that kind of blue from the plant source was never lost, was, however, replaced by chemicals. The blue from the snails was lost by the Hebrews around 600 AD, and by the Romans around 1500 AD, was lost until about the beginning of this century.
I remember, I wondered, maybe you did speak about the Virgin Mary, but I remember in the Tate galleries in London, the blue being washed out of so many great paintings, the Virgin Mary's robes, the Virgin Mary in a boat in the water, and I wondered if the sense of loss or the use of the word loss is connected here. And
I think you have the beginnings of a poem. Really, that is there.
Thank you. I was wondering, would you be able to discuss Prussian blue briefly? And also, are the snails cultivated today? Or are they still in a natural situation?
The snails seem to be not endangered. Certainly the Murex trunculus, I've seen it in Provence and Marseille, and abundant. They don't taste too good, so they survive. But they are eaten also. The snails have survived. They're not endangered, it seems. I don't know about South America and the other species. Prussian blue, so Prussian blue is another interesting story. It is the first successful modern chemical pigment. Um, it also is timed again in the first decade of, I think, of the 18th century, the same time that I mentioned for the rediscovery of porcelain. And in German, it's sometimes called Berliner Blau. And it was a serendipitous discovery where some bull's blood was treated with potash, which is potassium hydroxide, which is lye, and with iron filings in it. I don't know where. And so it is a chemical compound which is basically the organic. You can make Prussian blue from any organic source. It does not need to be bull's blood. The organic source is the source of cyanide, of carbon and nitrogen, and it's a potassium ferrocyanide for the chemist, but it's a very interesting material in a number of ways, and it is the source of the other story I didn't tell you of the 19th century, supposed rediscovery of the snail indigo by a Hasidic rabbi in Radzin, who toward the middle and end of the 19th century produced a blue. I'll tell you a little bit of the story because it's a fun. These are stories are fun. So he was an interesting, ambitious guy with a lot of practical learning. Started a factory in Radzin in 1870. He got it in his head to rediscover the biblical blue. So he went with 10 of his followers to the Naples Aquarium, the world's greatest biological research station of that time. I can just imagine the 10 Hasidim in black traveling in warm Italy, and he advertised in a local paper, giving the description of the Bible of the snail that produced things and how long it lived. The Talmud had that. When you advertise for something, you offer money, you get it. Yes? And this is Italy. So they brought him the ink sacs of Sepia officinalis, cuttlefish. And it fit. It stained his hands, but washed out. So he knew he had to do some chemistry. So he goes back and he does some chemistry. And what he did eventually, to this day, his followers are selling on the streets of Jerusalem that blue that group has made for 140 years, since 1870. They are selling it as the authentic Techelet, competing with these young guys over here. But what they have made is using the sepia ink sacs as the source of the CN. They essentially have made Prussian blue, and they're coloring the threads with a. They don't think they've done that, but that was reestablished. Okay, sorry, long story.
We hear about psychological effects or moods associated with different colors, mood,
Yes.
things like that. Are there any psychological effects or physiological effects related to the color blue or chemical reactions that
Yes.
take place in individuals who are looking at
Don't know, but that's a good question. We have learned that there are all kinds of responses in us to other sensory inputs on us that we recently there was the story about taste receptors in the inside of us, and so there may be some response to certain colors. There have been several books, including a recent one, about the color blue and its cultural history. I forget for the moment the French author who has written a treatise, who's writing a treatise on various colors, and also black and white. Not colors, but still the feeling of them. I think most people have, it's interesting that the response to the kind of blue which indigo represents is often, it's not, to me, from my experience, maybe it's because I'm just too interested in that particular pigment, but it's not any sense of the blues, though that must have been based on something. It will be. You will have a lecture about modern new shades of blue. But the response I have, I'll tell you about personally, is I have a response of sinking into that color. It is so deep that I feel I'm going into it. And it's not a threatening kind of, it's not a drowning kind of sinking. I'm just drawn into it. It's just my response. There was okay.
You've discussed and illustrated indigo as covering a spectrum
Yes.
of colors, but on the rainbow, it's described as blue, indigo, violet. Is there a specific place on the spectrum that would fit in with your description of indigo?
No. There is, so yes, there's probably a definition among color chemists, so they could, when you say indigo, but you've seen what happens in color descriptions. I mean, how can you describe, let's take something else, teal. You're going to have trouble describing what teal is to people. And yet someone knows when they've seen it somehow. And it may have, the inventiveness of advertising takes over in the naming of colors in modern times. And so with that comes a local description of a color is very specific, and maybe it can be copyright, I don't know, a color name for a certain region of the spectrum. But my feeling is no, the best we can do is that range is defined historically. Let me tell you one little story. So I mentioned there's a column of the Talmud where Rashi, I didn't tell it, Rashi is Rabbi Shlomo Yitzchaki, a medieval Franco-Jewish exegete who's commenting on the Talmud. And he comes to that section, they all stop there and say, what kind of blue is it, that fringe? And he no longer has a fringe to look at, so he can't tell what its color blue is. So he tries to describe the blue, and he comes to the conclusion that it is a greenish blue. And to use it, he describes it in the Talmud by the word for leek, poirot. And the word does not exist in Hebrew. So in the Talmud, you have the French poirot transliterated in 1097 into Hebrew, and to this day remaining. I think it's an incredible interchange of cultural change in what you think are, and the similar way elsewhere in Jewish literature, as much as in the religious literature, as much as the Hellenistic influence, I just think of how attractive Greek philosophy must have been to an intelligent Jewish kid in that Hellenistic period. They're fighting the Greek influence, but they can't find the words for something, so they use a Greek word, and they just transliterate it.
There's a plant we grow here and maybe elsewhere called false indigo. Has that ever been part of this story?
I don't know that plant. I wonder.
Baptisia. I don't know if there's any
No,
plant
I don't
folks.
know. There was an American slave-based indigo production in the South that I think that dealt with, I'm not sure if it was woad, or even that I don't know enough about whether it was woad or the indigo, but I don't know that plant. False indigo. Very
Thanks.
interesting. There was one in back of you there.
Now you mentioned in your lecture that there is an amino acid that has a role in the color purple.
Yes.
So, and you mentioned you can extract purple out of every one of us. So, is there some other amino acids that also have an integral part in other kinds of pigments that are expressed in other
Yes.
ways through different kinds of organisms?
Yes.
And if so, what would be some examples?
So the other big story with natural products, so many of our pigments are based on plant sources or animal sources. The very interesting one is cochineal or chemist. So this is a brilliant red. The red is the chemical carminic acid. And it's produced, the cochineal was one source of the Spanish wealth, along with silver mined. It is produced by beetles on cactus, and the beetles are grown on the cactus, and then they're scraped off and crushed. And the beetles, once again, they overproduce the chemical, and I don't know the reason, but somebody probably knows why that beetle. A similar beetle growing in Kermes is the eastern version of cochineal. This beetle, when you grind it up, half of its body mass is this chemical. I mean, it's pretty incredible. So there is a very good, so how does the beetle make carminic acid? I don't know that story. Maybe somebody in the room knows the organic chemistry of that biochemical processing. There are other colors used also, but the cochineal Kermes story is the most dramatic one. Sure. Good question.
Painters not being able to duplicate Giotto's blue would often scrape the blue off of his frescoes to use in their own paintings. And they didn't take any other colors. And I was wondering if there was other times when there was a black market or it was so valuable that indigo was like traded.
Yes, that's a very interesting point. So why the ultramarine is blue is another very interesting chemical story. The usual pigments that give blue are copper salts. We know them as malachite, for instance, or turquoise in our common usage. They look greenish, but they are blue. A copper sulfate, everyone has seen crystals of that. Very, very deep blue, beautiful blue. The ultramarine is a very unusual pigment. This is a very interesting story. So this recovery, I don't know of any other story except the following peripheral one. This has to do with bayeta in Navajo blankets. So the Navajo a good red is hard to get. And at some point they bought Spanish blankets, Spanish fabrics, and unraveled them in order to use the red thread in a classical chief blanket from about 1870 Navajo production. Those very nice geometrical motifs. The red, the cloth was called bayeta, and they bought this. But now whether that cloth was possibly colored with cochineal, which might have come from Mexico to Spain, would have been an interesting double migration of this. I think by 1870, the first synthetic dyes were used for the red. Yes.
I don't know if the snail has the blue as this for the same reason that the octopus, when it's startled, gives away an ink.
Yes.
So that it can.
That's a good question. So that ink of the octopus is the material which I mentioned this Radzin rabbi used to make Prussian blue. I don't know why squid ink, or in general, is dark colored. Perhaps somebody in the room knows that. But the snail never turns blue. You might have thought that might have, but it doesn't. It always remains that flesh color. But that snail is chemically so sophisticated, a veritable killing machine, that it wouldn't surprise me if it used the blue in some way we don't yet know. Thank you.